Hello, this is Dr. Renee Dyer. In this video, we're going to discuss the time value of money. Let's start with some basic definitions. The time value of money is the idea that money that's available today is worth more than the same amount of money in the future. And this has to do with potential earning capacity, interest rates, inflation, as well as purchasing power. Present value is the current value of future cash flows discounted at the appropriate discount rate. So when we're discussing present value, we're discussing discounting. Future value is the amount an investment is worth after one or more periods. When we're discussing future value, we are discussing compounding. One thing to note with interest rates, on the formula, it is listed as lowercase r. Sometimes you will see that as lowercase I or lowercase k. Interest rate is defined by how it's being used. So in present value, we call our interest rate the discount rate. In other settings, it is called the cost of capital or the opportunity cost of capital. If you're an investor, we call this our required return. All of them are the interest rate in the problem, but it may be titled or named differently depending on how it's been used. Here's a timeline just to help you understand the difference between present value and future value. Present value is at time zero, so that is today. Anytime we're working problems and it wants to know how much something is worth today or how much should I save today, we're talking about present value. Future value is any time period from time 1, 2, 3, and forward. So it's looking into the future, anything beyond time zero. So let's talk first about future value and the effects of compounding. The first formula is for simple interest. With simple interest, you earn interest only on the principal. You do not earn interest on the interest. So the simple interest formula is principal times interest rate times time. If you are asked to solve a problem with simple interest, please note this formula tells you how much interest you have earned. To get the answer of how much money do you have at a certain period of time, you have to add that interest back to the original principal. With compound interest, you are actually earning interest on the principal and on any interest you have already received. So you're earning interest on interest. This is a wonderful thing if you're investing or savings because you can let your money work for you. You hold it and you will continue to earn interest and earn more interest on the interest you've already earned. However, there's a downside. If you have a credit card, you are also charged interest on the interest that you earned because you didn't pay your balance in full. So it can be very damaging in that type of situation. But for the remaining portion of this video, we are going to talk about earning interest on interest as a good thing for investing and saving. Here's the general formula for future value. Note the variables. FV is future value, PV, present value, lowercase r is your interest rate expressed as a decimal in the formula, and then T is the number of periods. Please note that with the interest rate again, depending on the formula that you use, it can be a lowercase r, a lowercase I, or a lowercase k. Time can also be a lowercase t or a lowercase n. If you were calculating this formula with the calculator, your 1 plus the interest to the t, you would use your key y to the x unless you're squaring it. So anything, any exponent beyond 2, you would need to use your y to the x key on the financial calculator. Let's look at an example. Suppose you have $100 for 1 year at 10% per year. What is the future value in 1 year? The simple interest would be 100 times 10% times 1 year. So you would earn $10 and you would have 110 at the end of that first year. If you use the future value formula, 100 times 1 plus 10% raised to the 1, you're still going to have $110. But what if you hold that amount in the bank or wherever you have it for another year? In this case, you would have $121 if you're receiving compounded interest. Now suppose you leave the money in for another year. How much would you have in 2 years? Using the future value formula, you would have 100 times 1 plus the 10% interest raised to the 2 years. So you would have $121. So with simple interest, in 2 years you have 120. With future value, with compound interest, you have $121 at the end of 2 years. So where did the extra dollar come from? That extra dollar came from earning 10% of the $10 you had earned in that first year. So that's what makes compounding such a wonderful thing when you are saving and investing. A couple of important relationships you need to remember with future value. For a given interest rate, as time increases, future value also increases. For a given period of time, as the interest rate increases, future value will also increase. Now let's talk about present value. This is the current value of future cash flows discounted back to time 0 on the timeline. So it's the current value of an amount to be received in the future. Present value answers questions such as how much do I have to invest today to have some money in a certain amount of money in the future? Or what is the current value of an amount to be received in the future? Either way, we're looking at today. The present value formula is just the future value formula rearranged. So it is present value equals future value divided by 1 plus the interest rate raised to the time period. This is discounting. So with future value, we're multiplying, we're compounding. Future value is always going to be a larger number than present value because we're dividing, we're discounting. So future value is always a larger number than present value. So if you look at this problem here, what is the present value of $100 due in 3 years if the interest rate is 10%? So if you look at our timeline, we have $100 at tick mark 3. How much is that worth at tick mark 0 today if we can earn 10% interest on that money? You can see the formula below the timeline or see how we would put it into the financial calculator. Either way, we would have $75.13 today. That's what that $100 is valued at today, if we could earn 10% interest on that for 3 years. Important relationships with present value. For a given interest rate, as time increases, present value decreases. For a given period of time, as the interest rate increases, present value decreases. Notice that present value does just the opposite of future value. And again, this is because we're discounting with present value. We are compounding with future value. If you were to rearrange the future value formula to solve for the interest rate, this is what that would look like. Because you have a fraction in the exponent, that is very difficult to calculate just using the formula. Using the Texas Instruments BA 2 Plus makes solving for the interest rate very, very easy. So we will use the calculator to do that. Also, here's the formula for solving for n, or the number of periods. It's a linear function. Again, it's much simpler, much easier to do using the calculator. Here's an example of solving for the number of periods. You want to purchase a new car and you're willing to pay $20,000. If you can invest at 10% per year and you currently have $15,000, how long will it be before you have enough money to pay cash for the car? Here's the calculator solution. We would do 10 IY, and the calculator knows that that's an interest rate, so you don't make that a decimal and you don't put the percent sign. Present value is how much we're investing. That will be a negative $15,000 because that money is coming out of our pocket, going into an investment or a bank account. We want to have $20,000 future value, and we are computing for n, so it would take us 3.02 years. Remember that it's very important that PV and future value, FV, are opposite signs. If not, your financial calculator will give you an error. So whatever money you're investing or whatever money you're paying back is always negative because it's coming out of your pocket. Money coming to you is going to be positive because it is coming into your pocket. Last thing is the rule of 72. I think this is just a wonderful formula. I was a student at East Carolina when I first learned the rule of 72. So the rule of 72, depending on how you formulate All right, the last thing is the rule of 72. I absolutely love the rule of 72. I learned it as a finance student at East Carolina University, and I was just amazed that learning how to double your money, or how long, or what interest rate you need to double your money, was so simple. So the formula can be written two different ways depending on what you're wanting to solve and what information you have. So to find out how many years it takes to double your money at a certain interest rate, your formula is years equals 72 divided by the interest rate. So here you can see 9 years, if we could earn 8%. 72 divided by 8 take us 9 years to double our money. You can also calculate for what interest rate you need to double your money in a certain time period. So if we wanted to double our money in 9 years, we would have to earn 8% interest. So remember that the rule of 72 is either years equals 72 divided by the interest rate, or if you're solving for the interest rate, it is 72 divided by the number of years to double your money.